So some basic vocab here to start the day. We have a set, which you've seen sets last year. Is everything okay? Okay. We've seen sets last year. The set notation are these little curly brackets. What are the objects in the set called? Could be if it was in the context of, presenting the solutions to an equation that you just solved.
At this time, solve for class. Please have the auditorium. Thank you.
Okay, they're just called elements, so if you see elements in a set, pretty straightforward. I know you did this last year, set builder notation, where you presented your solutions in curly brackets. So, did I start before the bell rang? We're just off because the bell's scheduled. Anyway, all right. Set builder notation. So this is the set of all x's such that x is a whole number. That's how you would read that. Okay. So if this were answers to a question, your solution would be all x's such that x is a whole number. So in other words, it's just saying that you're talking about your whole number. So when we do read that, we use the term such that. The empty set, when there's no solutions, okay? So sometimes when there's no solutions, we just do this little zero with a slash through it. But what that means in set builder notation, it's a set of curly brackets with nothing in there. So it's just left completely blank. So that in math is correct and interpreted as having no solutions or nothing in the set. I don't know if you ever did subsets last year, but subsets are just a set within a set. So if I give you a set, so my set is going to be this. Does anybody know what that little weird capital Z-ish means in math? Ever seen that before? Nobody? No? What if I offered a bonus point for someone to answer? Would that be helpful? No. So maybe you've really never seen it. Z is the math symbol, and it's kind of got like a double thing going on there. Means the set of all integers. Put that in parentheses. Okay? So let me remind you, or you remind me. What are the integers? What are integers? Give me an example of an integer. Yep. 1. Give me an example of another integer. 2. 3, obviously, okay, and so on. How about 0? Is 0 an integer? Raise your hand if you think 0 is an integer. Raise your hand if you think it's not an integer. Okay, quick clarification. When we raise your hands with straight elbow. Okay? Raise your hands if you think 0 is not an integer. Okay, interesting. How about -1? How about the negatives? Is -1 an integer? Raise your hand if you think it is. Raise your hand if you think it is not. If you think -1 is not an integer. Wow. I hate to break it to you, but you're all wrong. Integers are any whole number, either negative or positive, or 0. So your integers, I didn't really anticipate doing this, but we will review it, are -3, -2, -1, 0, 1, 2, ... Those are all your integers. Huh. Okay. Now, so you guys were just referring to, most of you thought that integers were just 1, 2, 3, 4, and so on. So you were leaving out 0, you were leaving out all the negatives. What you guys are referring to, just 1, when you just say 1, 2, 3, those numbers are natural numbers. And that symbol is kind of a capital N, natural numbers. use the number symbol. So that set would look like 1, 2, 3. And when some of the younger years, you would have called them counting numbers. That makes sense. Like when people naturally start with, counting, they say 1, right? So, truthfully, if someone said start counting, you could -5, -4, -3. You could do that. You could say 1.1, 1.2, 1.3. These are all versions of counting, but naturally, when you start with my 2-year-old at home and I say count, he says 1, 2. So naturally, you would start counting with 1, and so counting numbers, natural numbers are that set. So back to this idea of subset, the natural numbers are a subset of the integers, you would say. Okay? Right? Do you see how the natural numbers in their entirety are found within the larger set? Out of the math context, German shepherds are a subset of dogs. Is that fair? Okay, so pretty basic idea here. But let's go on with these kinds of numbers. There is a name for 0, 1, 2. If you start with 0, there's a different name for that. What'd you say? Whole numbers. Very good. Whole numbers. I'm going to do this to separate. And is it a W? I almost have to look that up because it doesn't come up much. I don't know if it is a W. You would think integers would be I, wouldn't you? And it's not. It's just weird Z. It must be. You'd have to look up the history of that and find out why it's a Z and not just an I. But maybe another language that it's that in. I'm pretty sure this is. I'll let you know if I'm wrong, but I think it's a W. Not totally. Z is actually one of the most important ones. Integers, that you should be comfortable with the fact that that's that capital letter Z. The natural and whole numbers we don't really use as often in math, so I'm not that worried about it. But when you hear those terms, though, when you hear whole numbers, you need to know what they are. Starting with 0, natural numbers starting with 1, and integers is all of them positive or negative. What kind of a number is like 1.1, 1.2, because they don't fall in any of these categories? .1 starts with an R. Rational, very good. So your rational numbers, we can't really write out a list of rational numbers because not only do they go infinitely positive and infinitely negative, but you've got an infinite number of numbers between 2 and 3, right? You've got 2.1, you've got 2.01, you've got 2.001, and you can keep, it's kind of a weird concept, right? That there's an infinite number of numbers just between 2 and 3. But you can't really write it out in a list format. But rational numbers are all numbers that really can be written as a fraction. So what can be written as a fraction? Can 5 be written as a fraction? Yes, how so? 5 over 1. Can 2.3 be written as a fraction? Yes? What? What would 2.3 be? 2 3/10, and obviously if it's a mixed fraction, then we could change it into an improper fraction. How about 2.5698? what? What's that fraction? 2 and 5,698 over, what place do we go out to? Tenths, hundredths, thousandths, 10,000ths? So over 10,000. Okay? What cannot be written as a fraction? Raise your hand if you know. 2.3 repeating. Good question. So that's 2.3333333 to eternity. Anybody disagree with that? Go ahead. Okay, who can help? Yes, that is a third. That's 2 and 1/3. So that can be written as a fraction. So what is the key that we're looking at for a decimal that cannot be written as a fraction? We obviously know all whole numbers, all integers can be written as a fraction. You just put them over 1. But what is the key when you're looking at a decimal number that tells you whether or not it can be written as a fraction, tells you whether or not it is rational? Go ahead. It's not repeating with a pattern, okay? So the example you gave me was 2.3, and it was repeating so that if someone stopped and just put ... everybody would know the next number is 3, and the next number is 3, and the next number is 3. Versus something that repeats without a pattern, and it's completely random, like the number pi, okay? Pi, obviously, is 3.14 1592654, and that doesn't just stop, right? It stops on your calculator screen because the calculator screen is only so big. But we all know that that goes on infinitely without a pattern. And when you don't see a pattern, that's your indication that it is irrational. Yes? Okay, so pi 3.14159 ... I'm going to say that that is irrational. Oh, that's why our integer is an I, because irrational is that capital I. Okay? So repeats without a pattern. If it repeats with a pattern, it's rational. If it just flat out stops, so like 8.275, if it flat out stops, it's rational. It is rational. If it goes on infinitely, now some are rational, some are irrational. If you can find a pattern, it's rational. If you cannot find a pattern, it's irrational. You guys dealt with the number e last year. Correct? E to the first power. Well, that certainly looks like it has a pattern, but it doesn't. E is another irrational number. That's 7. You think 1828, 1828, 1828. I don't believe it does that forever. But that is an irrational number as well. Any other irrational numbers you can think of? On the calculator, you really can't. You just have to know that. Pi and e are the two main irrational numbers that we work with in math, at least at this level. So it's a good point. You wouldn't be able to. Intersections and unions. Does this look familiar? Did you do this last year? You did. Okay. So we know that an intersection between two sets is what they have in common. So, and it's the upside down U. So if you look at this set and this set, their intersection is, I need to get my class list out here, is what, Leah? Where's Leah? Okay, hi Leah. What's the intersection of these two sets? What numbers, if any, would you list as the intersection? What's that? You're not sure. So an intersection is where they overlap. What elements do they both have? Okay, so this set has the number 3. Does the other set have 3 as well? Yes, so 3 would be in there. So is it clicked? Okay, so what else would be in our intersection? 7. Anything else? Nope, just 3 and 7. Very good. I'm going to bring up Venn diagrams now, which I know you did last year as well, because Venn diagrams, the overlapping part is the intersection. So if you were to list all these elements, 3 and 7 would be in both circles, so they would be listed in the middle. 5, 6, and 4, 5, 6 would go over here to kind of complete this left set, and 8, 9 would go in here to complete the right set. So I just put a little intersection symbol in there to remind you that that's where they overlap. Okay? Now, a union, on the other hand, is all of the elements that are in both sets. So you're kind of uniting them. So from a Venn diagram perspective, your union is really going to be the whole thing. All of these things are in the union. So if I, now without seeing the numbers, if I take the odd integers, and if it helps you, you can kind of write a list out. That would be -3, -1, 1, 3, 5, and so on. And we want the union with the even integers, which would be like -, -2, 0, 2, 4, and so on. When you unite these two sets, what do you get? Go ahead. All integers. What's your name? Yeah, nice job. All integers. So we could say just integers. Or we could use our symbol. Or we could use kind of that set builder notation. So all x's such that x is an element of the set of all integers. Okie doke. Any questions so far? Yeah, go ahead. Which one? Oh, good question. Thank you. Is an element of. So, yeah, we haven't done that yet. So that's new to you. You haven't seen that from last year? Okay. I'll do that. Is an element of. And it looks like an E, but kind of a weird E. It's like a C with a little line in the middle. So here's our C with a little line in the middle, means is an element of. So when we would read this, all x's such that x is an element of the set of integers. It really just means your integers. Okay? So if you see that. Thank you. Take some of these things for granted. All right. Absolute values. You all know what this is. Here it's just written in kind of this set notation. So what is the absolute value of x equal? So it's kind of a piecewise function type notation. Okay? So if x is greater than or equal to 0, so if x is 5, then the absolute value of 5 is what it is. It's just 5. Right? So if x is greater than or equal to 0, the absolute value of x equals x. But if x is less than 0, aka a negative number, then the absolute value of x, so take a number like -5, the absolute value of -5 is the opposite of what it is. Does that make sense? Okay? So it's just kind of presenting it in a set builder notation, which we all know makes it way more complicated than it really is. But you do have to understand and know how to read this notation. We will kind of use some of that notation much later in the year when we're into calculus. It's just really the more professional way of presenting in math, in writing, what the absolute value definition actually is here. as opposed to we all know absolute value negative 5 is just 5, and we take that for granted a little bit. Simplifying, you'll do a bunch of simplifying questions on your homework tonight. Shouldn't be too difficult, but it's going to get a little bit maybe more intensive than it was in Algebra 2. So on this first one, what would be the first thing I would do to start my simplifying process here? Jalen, where's Jalen? Okay, what would be the first thing you would do here? Okay, so what would that look like? 4x squared plus 25. Raise your hand if you think otherwise. Or, oh, okay, we got a few people. I know Adam. So what's your name in the front here? The glasses. Josh. Plus 25x and plus 25x? Okay, where's that middle 25x coming from? And tell everyone where that's coming from. You're onto it, obviously. We just have to, you know? Wait, Jalen wants to correct her wrong. What do you know? What did you forget to do?
It's like the quantity of the
Right, so you forgot to kind of consider the foiling process, right? So, and then let's go back to Josh. Right, so Josh sees that outer is 10, it's the outer and inner. The 10x and the 10x doubles to make 20x, so we'll get rid of that. 4x squared plus 20x plus 25, okay. Anything else, Jalen, you would do in this first step? So you've just handled a piece of that. Would you do anything to this? Yeah, why write that extra step? So we would distribute our 10. It's a separate term completely, so we can distribute that to get 40x squared plus 30x. Good. Okay? So there's our first line of work. Tell me what we would do next, Connor.
Then you would distribute the 6 to the 4x squared plus 20x plus 25.
Very good.
And then you add this, and nothing would happen to the other.
Yep. Very nice.
I don't know what we call that after the plus set side. No, I trying to find that.
So, well, you said all I needed you to say. Are you trying to take it further, you mean?
Yeah, and then just add both of the sets, what they're called, or sides.
What's the phrase he's thinking of?
Yeah,
What comes next?
That.
Anybody?
And like,
Yeah, like terms. Combining like terms.
okay.
Good job.
I was just trying to find it.
No, that's okay. That's all right. What was your name? Jay? Jack. Nice job. Jack says combine like terms, and he's correct. So we've got our x squared terms, which is going to make 64x squared. I like to cross them out once I've accounted for them. 120x and 30x is going to make 150x, and your constant is 150. Now that you would be expected to do without a calculator, just so you know. Okay, there was nothing in there that was crazy. Maybe 6 times 25, but you know, that you definitely need to know how to do in your head. Okay? And if all else fails and you need to do it on the side, 25 times 6, like old school, you can do that. Okay? All right, the next one here is a little bit, you know, a little bit heavy on the parentheses. What would you do first to simplify this? Take a look at it, think about what your answer would be, and then I'll call on somebody. Where's Alyssa? You're Jess's sister?
Yeah.
Okay, good. Alyssa, what would you do? Okay, so I'm going to write 6 plus 4x and tell me what to write from here. Very good. So she's Distributing that negative sign, perfect. And what would we try next? Nathan. Who's Nathan? Oh, there's two Nathans? Nathan Z. Nathan Z. What would you do? Okay, so he's going to combine like terms. You got a little bit of an option here. Some people might distribute the 4x first. He's going to clean this up a bit, which is good. 7 plus 2 is 9 minus x. Then we would distribute the positive 4x, so the 6 is going to hold tight. We're going to get plus 36x minus 4x squared. And then we're pretty much done, yes? No? Why not? You're Steven, right? Okay. You got to put it in what? I guess it's just... Yeah, what were you going to say? Simplify, how? Now that's not simplifying, that's factoring, which are actually opposite operations. Okay? So let me talk about that. That's just a basic vocab thing. If someone shows you this and says to simplify, simplifying is the process of multiplying things out, going through order of operations. So this would become x squared minus x minus 6.
Pardon the interruption. At this time, would Preston please come down to the auditorium? This time, freshmen should come down to the auditorium. Thank you.
If you actually go and then factor that, you're undoing your simplifying. This is so common. It's just making sure we've got these words straight. So factoring is the process of going from the simplified version back to x plus 2 and x minus 3. That's factoring. So simplifying actually means to carry through all your multiplication in PEMDAS. So this would be the simplified answer. So that is simplified. But we will get more into factoring. It's just standard polynomial form is to have that highest exponent first. I don't know if there's really a name for what you're doing. Yeah, oh no, and you should. And if you check your answers in the back of the book, your negative 4x squared would come first. And then we have a simplified, just polynomial form written.
I just call that reordering.
Yeah, yeah, reordering.
There's no real term for it.
Correct.
Just reordering.
Yep. All right, so that's where we are in the front. Are there any questions on that?
No.
All right. I want you to take the next,
Question.
5 minutes to work on these three. Yes?
What's different about the brackets to the parentheses?
Not much. Nothing.
Just,
Yep.
you know, was matching that thing out.
Sometimes it helps for your visual organization to see a second set of brackets versus a second set of
You
parentheses.
just never really know with math if it's some
Right, that's a good question. I'm glad you
completely
asked.
different operation or
Right.
just nothing.
Yep.
And after trig, I'm not taking risks on that.
Mm-hmm. Mm-hmm. Okay, so will you just bring it to Monday? Okay, great. Thank you for letting me know. Yes. Mm-hmm. We'll talk about that. It's not as bad as it looks. Did you finish your 3 problems? Great. Raise your hand if you're done with all 3 problems. Raise your hand if you need just a little more time. Once you're finished, I encourage you to check with your neighbor if they're both finished and see if your answers match. If not, have a little discussion, check over each other's work, and see if you can come up with an agreement between the 2 or 3 of you. Yeah, well, this is the long one today.
Yes. I remembered that, but I didn't know. Normally, you don't look at
When does class go to?
9:14.
My last.
I can't find my
I like this video style more because one, I know it's reported constantly, and 2, there are actually questions there. Just come back to last year and let's do that.
Okay, let me hear. Where's Stephanie? Stephanie, what did you get for the first one and the 7 minus 4 one? Yep. Raise your hand if you got that exact same thing. And your paper. So Nathan Z got it. Stephanie. What'd you get? Raise your hand if you got that as well. Excellent. That is the correct answer. 64y squared minus 160y plus 95. But this is where our little game will come in. We're going to play teacher for a minute. So here is the work. Take a minute on your own. Do not chat with the neighbor here, and see if you can find the mistake. because this is where I'll like give bonus points if you find it, but it's not about who raises their hand. So you don't even need to raise your hand, because I'll just randomly start with somebody, just pick a number, have you pick a number, and I'll start. And Elizabeth. You're Elizabeth?
Yeah.
Did you find a mistake?
She subtracted the 7 and the 4, so she got 3, and then the other 3, that was inside the bracket, she added those, she gets 6, and then added that to the negative 5.
Stephanie, is that what you did? Did you get this to be 3? So yeah, you got it. Just kind of combined like it was actually tough for me to say exactly what I would say. Yes, you got that right. It was hard to see because her work isn't really shown what she did, but yeah, it looks like she just took that down and then she's clarified that she did just combine this with this with this with this. But the reality is we have a whole host of distributing that needs to happen. And we would never do 7 minus 4 because this is 7 minus 4 times the brackets. And we all know that multiplication has to come first, right? So she would need to take the negative 4 and distribute that through to everything, okay, which is going to give her 7 minus 12 and so on and so forth. And then I'll pull mine up right here. You're distributing your negative 4 to everything. And if you chose to combine those first and then distribute, you could. The reason I just didn't combine, I didn't want to combine, distribute, and then recombine again, because you're going to have to eventually. So I just decided, who cares here? I just distributed my negative 4, careful of your signs, and then we have different terms to combine. Although, now that I'm thinking of it, oh, I was going to say, how did her 16 stay as 16 and that is not 64? Because we didn't, again, distribute, okay? All right, so on the second one, without seeing mine, Haley K, where's Haley K? What did you get? 7x squared plus 15. Raise your hand if you got something different. Raise your hand if you got that exact answer. Oh man, we can't play teacher. That's correct. Actually, Haley and Matthew got it right. But you see how fun it is when we can find a mistake and evaluate, right? So that is the correct answer. So doesn't sound like we need to discuss that unless anyone has a question. Okay, and on the last example, Michelle. Where's Michelle? Hi, Michelle. What did you get for the last one? 2. Raise your hand if you got something other than 2. We all got 2. Every once in a while, some people will take the absolute value of negative 8 and do 8 plus 6 and get 14, which is obviously incorrect. You simplify within the absolute values first as if they're parentheses, and we get negative 2, and then we apply the absolute value of negative 2. Nice job. So let me explain the homework in the bottom corner here. What this means, and this is often what I'll do, I want you to span all of these types of different directions that you're going to come across on your homework, but you're only doing any number that ends in a 1, a 5, or a 7. So you're doing 1, 5, 7, 11, 15, 17, 21, 25, 27, because even the odds would obviously be too much. I mean, I want to keep it reasonable for you. Again, you're doing this on a separate sheet of paper. Write down the original problem always, okay? Because if you get something wrong and I want to grab your paper and we want to search for your mistake, it's start to finish and we have the whole problem. I also, like I mentioned yesterday, do not want you to erase something, okay? I mean, if you find your own mistake and you erase and fix, that's fine. But if you really can't find your own mistake, I don't want you to, I mean, if you want to start the problem from scratch, you can. But don't erase the whole thing and leave it blank and then come in tomorrow and tell me I couldn't get number 125. And I'll say, well, let me see what you worked on, and I see nothing, right? I want to see what you had done and where you made your mistake. Does that make sense? Okay. So if you're going to erase it all and retry it fully and completely, that's fine. So I'll still have something to look at. But I don't want you to ever have anything completely blank.
That's not 1 to 125 I Pre Calc.
Yeah, I know, everyone does. So there's your homework. Answers are in the back of the book, okay? And I did find one quick thing here. I did find it in your textbook, so we can talk about it. This is your, I gotta move that mouse because it's driving me crazy. These are those symbols I was talking about, these kind of universal symbols. So here's our natural numbers, capital N. Okay, we use that on our notes. Whole numbers is in fact a W. It doesn't really come up as often, but your whole numbers. Your integers are Z. Your rational numbers, Q. Interesting. We talked about rational numbers. I actually never gave you the symbol.
I know why it's the Q.
Tell us why, Connor. Why do you think it's...
Because the R like that is all real numbers.
Correct. The capital R is real numbers. And I don't know. It could be a different language. Irrational is the I we said. And then actually there's a nice little, take a look at this. There's kind of your, it's not a Venn diagram, but I guess in some way it kind of is. You've got your two different categories, real and irrational. Irrational is irrational. I'm sorry. I said that wrong. The two different categories, truthfully, would be real numbers and a separate box for imaginary. Yes? Or complex. And imaginary is imaginary. Once you're in the real number system, you're either rational or irrational. You have to be one of those two things. If you're irrational, you're done and over with. That's the only type of number you are. You're real and irrational. If you're real and rational, you may or may not also be an integer or a whole number or a natural. Okay? So if I give you like the number 1, you're a natural number. But that also inherently makes you a whole and inherently makes you an integer and a rational and a real. Okay? But I could give you just 0. 0 is a whole number, but it's not a natural. It's a whole number. And if it's a whole number, it inherently is an integer and a rational and a real. If I give you negative 3, you are an integer, but you're not a whole number and you're not a natural. You're an integer. So you're negative 3, and inherently you are rational and real. Okay, and so on and so forth. And then when you get outside the integer category, any of those decimals that are finite, like end, or are written with a pattern would be your rational. Okay? So that kind of organizes that well and gives you all these symbols. This is on page 6 of your textbook if you ever wanted to remind yourself. All right, so that's it. You have your homework. We do have a few more minutes